Hey, how's it going? It's Nick here, and today I'm testing my 3D printed press and seeing what we can do to it to get it to print some etchings. So this is going to be a nice behind the scenes video so you all can see the thought process and testing that kind of goes into revising and improving a project such as this 3D printed press. So today we've got a bunch of different variables to test. I've got the press printed in PLA, PETG, and ASA to see if the different plastics have different properties, can kind of push it over this threshold to print etchings. And I've also got a bigger gearbox to see if it just needs more power. And I've also, as you can see, I'm making metal rollers to see if the rollers are the whole thing holding it back. And I also have a metal bed plate to see if it is the kind of press bed that is holding us back. And so one at a time, we're going to slowly see which of these things is holding us back to cross the ultimate threshold of printing nice big etchings with aqua tint. So first thing we need to do is establish a testing standard. And so for that, I'm going to go ahead and tear myself some strips of BFK Reeves, and I'm going to go ahead and tub soak them. And I want to make sure I give it at least 30 minutes of soaking. Now let's go ahead and establish a baseline. I'm going to go ahead and print this on my metal Holbein etching press that I know can print etchings very well. And I'm just printing using some Cranfield Collegial Safe Wash etching ink because I figured that's a pretty easy ink to get in most places of the world, I think. At least I know in Europe and the USA it's pretty easily available. My paper, I'm going to go ahead and blot it with some newsprint. About twice is fine for me. Usually as long as there are no shiny spots on the paper surface, that's usually good enough blotted for me. And I'm going to go ahead and print this. So I've already got the felts kind of trapped in there. And it's kind of hard to tell you how much pressure to use. The only way to really know is to actually print your etchings. One small rule of thumb I've learned before is if you run it through dry with some newsprint and it kind of embosses the newsprint, then usually that's enough pressure. So this was my first attempt here, and you can see that it was actually a pretty good amount of pressure. You can see that all of the ink has pretty much been lifted from the plate. It might have been too much pressure. You can see my plate's a little curved now, but look at that aqua tint. That is a full 02 pitch black aqua tint, just like it was intended to be. It's a little scratched up because I've been using this as a test plate for a really long time, but you can see it's not very splotchy. That's a pretty good print if I do say so myself. So if I could get the plastic press to print something like this, I think we'd be in good shape. So let's go ahead and take that original classic plastic press design and push it to its limits and see what we can improve. So one of the first things that I've already done here that I've recently discovered is that, in order to get a good grip and travel through the press, I have put some skateboarded grip tape on the bottom of the press bed. And this just ensures that the rollers don't slip out when I'm trying to run it through with too much pressure. I've also tried gluing sandpaper to the bottom of the press bed, and that also works. But now that I ensure that the bottom roller won't slip from the press bed, I do like having the press bottom driven more than I like it being top driven. And just so I can keep the pressure consistent between the presses, I'm just gonna slide this plate underneath the top roller until the point where it does not touch the top roller, but as low possible as it goes. So you can see here, I'm lowering it just a tiny bit, but now this plate, when I slide it under, contacts the top roller. So I'm going to loosen it a little bit, and that's just kind of like the baseline pressure that I'm kind of going to reference between the presses. But I do have to lift the rollers a little bit because the top roller can't quite bite the top felts when they're this tight. The press bed is just too smooth. It'll end up pushing the felts back out. And so I'm going to raise it just enough so I can kind of get the felts trapped underneath the roller, and then we're going to lower it back down to get that pressure. And a bit sooner than I anticipated, we've already gotten our first failure. And so as I turn this around here, you can kind of see that the top roller has broken at the joint where it kind of connects into this bearing block. And upon closer inspection, this is the bottom of the top roller. So this is the part that had to be built upon supports. And so my guess is because it was built on supports, the first layer of this kind of bottom of the middle section of the roller doesn't have very good squish into itself. And so really I had 4 bottom layers, but there were 4 bottom layers that weren't really squished into each other. They were just like loosely stacked. So going forward, I'm gonna try something maybe like 8 bottom layers. That way, you know, it'll give it like 3 layers to loosely stack, and then the subsequent like 5 layers will really squish and fuse with each other. Another point of failure is this point where this kind of the screw from the pressure knobs is contacting the top of the bearing block, and you can kind of see how it's kind of like broken down into the shell of that part. And so we're gonna have to do something about that. One of the new things I've learned since I've started 3D printing is that you can change the level of infill in certain parts of your print. And so you can see in the original file that there's just kind of this hollow cavity of just kind of cubic infill between where that bolt meets the bearing block. And so we're going to go ahead and turn that part into a solid piece of plastic by changing it to 100% infill, but just in that spot. And to do this, we're going to go on the left hand side, and I'm going to click support blocker, and then I'm going to drop a little support blocker cube in that area, and then go ahead and resize just the support blocker cube. And so I'm going to make it long enough to extend out the top of the press body frame, and I'm just going to kind of encompass this entire little rectangular area. I figured since we're at it, we might as well reinforce that part where the threads kind of bite into the press body. I haven't had that part fail yet, but it's so little extra plastic that I might as well do it. And now we can actually change what the support blocker does. And so on the left hand side, we can click per model settings, and then on the third option over, we can change where things overlap. And so I'm going to go ahead and click that, and I'm going to look up infill, and I'm going to check infill density and infill pattern. And so on the left hand side of Kira, those settings should be now available. I'm going to go ahead and change infill density to 100% and change my infill pattern to lines. And then now when I slice, you'll see that where the support blocker was, in these areas it will be 100% infill, and so it'll be a nice solid block of plastic. So now moving forward, the PETG press and the ASA presses have that spot reinforced as a solid block of plastic. And so let's go ahead and test this PETG press and see how it fares. Right off the bat, it's a lot noisier than the other presses, and it feels a little, it's hard to describe, it's like squishier, a bit like floppier, gummy, I guess is the best way I can define it. It just doesn't feel as crisp as the PLA press. And ultimately, it looks like the gears of the PETG press just weren't up to snuff for this task. A press made out of PETG is definitely fine if you just want to print some relief, but dry point or etchings, I think definitely not. And just to see what would happen, I went ahead and took the PETG rollers and put it in a PLA press body and gearbox. And this is actually the clip from the beginning, and as you all saw earlier, the PETG rollers really couldn't handle the stress of this test. And then the way it broke was kind of interesting. Again, I think it broke at the spot where the supports kind of turned into the bottom of the roller kind of body, and it kind of looks like the kind of outer wall just didn't melt well enough or squished well enough with the inner walls, and so it was kind of like a skin just kind of peeling away like an onion. Kind of interesting, but yeah, that's how that went. Don't use PETG for any of the roller or stress bearing parts of this press. For the press body and the knobs and the gearbox cover and the handle, for that stuff, it actually worked just fine, but just don't use it for anything that's like, you know, handling pressure, anything that I have on white for the press. Lastly, let's go ahead and give this ASA press a shot. We're using ASA instead of ABS because my printer is loosely enclosed with cardboard and the smell still leaks through, so I prefer Polymaker ASA because I actually can't smell that at all, and it doesn't give me a headache. And so far so good, it actually handles the pressures quite well. I don't hear it screaming like the PETG press, and the rollers haven't shattered. So now that it's achieved the bare minimum, let's go ahead and see if we can print an etching on it. So first round, we're just going to send it on through, and it feels quite alright. But when we peel it back and we take a look at the print, we can see it's just a little bit light. And so I guess we're going to need to try some more pressure. And it's getting a bit tough to crank now because there's so much pressure on there. And so I printed this test handle here. And so you can see it's much longer from the point where it connects to the press. And so in theory, it should give me a lot more leverage. And so that's just more for comfort rather than me actually thinking it affects the durability of the press. And with that and a little bit more pressure, we can see we're getting better results, but it's not quite a rich black at the deepest end. And when you take a look at the plate, you can see it's still leaving a bit of ink behind. And so after painstakingly taking print after print, slowly lowering the pressure, we finally got something that I would say is a pretty professional result. Nice rich blacks at the deepest end and a clear distinction between each of the different stages. That's what I would say is a pretty good result. Now, for science, I have to go ahead and take this press until it's a breaking point, so I know what the weak points are and what to reinforce. And so I kept on lowering the pressure and I kept on taking prints, and it went for a little while, but eventually I got to a point where things got weird, where I would crank the handle but the press bed just wouldn't move. At first I thought it was the handle, like the hole for the handle was just kind of worn out, and so it was just spinning around the gears. Eventually I marked the gears and I tried to watch, and then I noticed that even though I could turn the handle, the gears weren't spinning. And so I decided to crack open the gearbox and see what was wrong. And so we can kind of see that the load was a bit too much for these gears, and we ended up stripping some teeth. But at least we did learn that it is possible to print full aquatint etchings on this press. And so I still had the PLA gearbox, and so I thought I would give it a try and see if that did any better. And to my surprise, the PLA gears actually held up better than the ASA gears. Though I will say it is still quite a chore to crank. It takes quite a bit of muscles, but look at that rich black aquatint. Anyway, I went a bit extreme and I made this big old 20:1 gear ratio, so 4 times the power of my old gearbox, and we're gonna slap it on and see how it feels. So with the plate inked, paper in, and at the same pressure as before, we're gonna go ahead and turn it through, and I will say it is quite effortless. I feel like it barely takes any muscle to turn the machine, and I don't even feel when the roller comes on top of the copper plate. It's just one smooth uniform movement. But I would say it's a bit overkill, and turning this is really slow. I would say with one turn of the handle, it moves the press bed about half of an inch, and so you're going to be turning this thing a lot just to move it through, which is fine, I guess, if you're just printing some etchings. But if you're printing relief and you want to go fast, I feel like this is a bit too slow. We could do better than this. So there should be a happy medium somewhere. And I'm a little disappointed. We're only halfway through this experiment, and it turns out all we really needed to print some etchings was just a little bit more gearbox ratio and to make one part of the press solid, and that's all it really took. I'm surprised that I was so close with my previous design, but that also means that there was really no need for me to buy that aluminum bed plate and the metal rollers. But you know, I already made them. I might as well make a balls to the wall maximum press, and so let's go ahead and see if it feels any different. To the credit of this piece of whiteboard as the press bed, it cleans pretty easily off of the surface. It's getting a little scratched up from the copper plate just kind of digging into it, but when I tested it for flatness with my machinist rulers, actually it's staying pretty flat and it's not really warping from the uneven pressure. So honestly, it's pretty impressive. But I imagine if you want to avoid these scratches and long-term damage, you might want to upgrade to a metal build plate or add a sheet of plexiglass on top. And I got this block of aluminum plate because it's already been milled flat, when I buy hot rolled steel plates, they're not really flat, they're a little bit curved. When I buy these aluminum plates, they're already machined flat. I assume they're being used for CNC purposes, but good enough for me. And so I'm going to go ahead and stick on a piece of plexiglass that I drew a grid onto, and that's going to be my press bed. And I've been running this one through the press a few times with enough pressure to print the etching and a little bit more pressure than that, and really it doesn't feel much different. It's a little bit heavier, which is good for helping it kind of grip into the bottom roller, but in terms of like overall print quality and kind of feel, it's not that much different than the hardboard one. And so I guess the only real reason to upgrade to a metal press bed is if you want long-term durability. So now we're going to swap out the rollers for metal rollers, and here we're going to go from a nice light 154 gram roller to a big whopping hefty 570 gram roller. And so this is just a metal pipe that I bought with a 1/8 inch thick walls, and I slided a kind of a 3D printed core into it to kind of help keep the spacing. But honestly, I feel like it didn't really do much. Really, I got the same kind of print quality. It felt exactly the same as I was running it through the press. And honestly, I kind of worry about if it's perfectly uniform across the way. Like, what if one side of the pipe is thicker than the other side? And really the only way to kind of make it a perfectly flat is if I had a lathe and I could machine it down a little bit to ensure that it is like, you know, a perfect uniform thickness all the way through, which I don't have, and which is why I thought 3D printing would solve that problem. But really, I can't recommend the metal rollers upgrade unless you have a metal lathe that you can use to machine down this roller into a perfect diameter after it's been glued on. And while it doesn't make sense to do it at this scale, it might make more sense if, for say example, we were going to make a 18-inch wide press and the plastic might bend a little bit when you're working at that long of a scale. So what do we learn from all of this? Firstly, PETG is not the best material for a printing press. Stick with PLA or something like ASA. Secondly, make sure the spot where the screw hits the bearing block is completely solid. We can actually get away with like 2 walls and like 15% infill as long as this spot right here is 100% infill. So that's really neat. And lastly, a little bit more gear reduction goes a long way. So I've engineered a medium-sized gearbox. And so this gearbox has a 10:1 gear ratio, and which is double the power of the original 5:1 gear ratio, but it's not quite as slow as that 20:1 mega gearbox that I made earlier. So all you have to do is remove your old gearbox, might be a bit destructive, and put in this new gigantic gearbox, and this is going to make printing etchings pretty much a breeze. So these gears have a much bigger tooth, and so they're less likely to slip, but the main downside is that they use a lot more plastic than the original gearbox. And so that 10:1 gear ratio is going to make it so that when you turn the handle once, the press bed's going to move about 1 inch, which I think is my golden ratio, kind of ideal kind of gear reduction. Unfortunately, bigger gears and a small form factor, you're going to have to use some supports, unlike the old printing press. Go ahead and slice these up with supports, and the important things again is so that this tall crank gear, you're going to be printing it solid. The middle gears, it's okay if they don't print solid, but here you can see the teeth aren't completely solid, and so you're going to go ahead and upgrade this wall line count until it's solid. So now you can see we're printing these teeth for the gears with 5 walls, so that way it is solid, and that should be good enough. You don't really need supports for the crank gear, but it keeps auto-generating them for this one anyway. And so you're going to assemble the gearbox pretty much the exact same way, putting the crank gear at the bottom and then the middle gear, so they kind of line up like that and mesh. And then lastly, this hex gear that interfaces with the roller, and then that's all the gears. They should just drop right in. And one new feature is now I have 2 locking tabs on the side of the gearbox. And so you just kind of slide this plate on, might take a little bit of wiggling, and then we're going to kind of have to like slide down and push it past that little locking tab, and then, you know, it's good enough to hold it for now, and it'll definitely hold it in place while the glue is drying, but it's not like a permanent hold. And it still makes the clearance whether you're mounting it on the top, you know, it doesn't extend down too far to the table, and it still makes clearance when you mount it onto the bottom. And you can still use your original handle and lock pin. Should be backwards compatible with the old press. But don't throw away your old gearbox just yet, because it's going to be future compatible with the next version of the plastic press, which is not quite ready for release just yet, because I still need to do some testing and finishing up documentation, but I'll give you all a little sneak peek. Version 2 is going to have asymmetric rollers, so we can use the smaller gearbox with less plastic waste, but maintain that 1 handle crank to 1 inch press bed ratio, as well as having up to a big 8-inch wide press bed, as well as having these extending folding wings. That way you can support larger press beds without them having, you know, be floppy off the edges of the press. All of this still printable on a small Ender 3 style printer with a print bed of 220 by 220 by 250. The larger top drum really makes it a lot easier for you to kind of print things like etchings and get higher pressure. It just climbs over your matrix a lot easier. All of this extra workspace, but I didn't want to take away this press's best feature, which is how portable it is. And so when you're ready to put it away, you know, if you're done printing or you need to take it on the go, the wings fold up and it doesn't take up any more space than the original design. Unfortunately, I have 2 exchanges that I need to finish in the next like 20 days, so I've got a pretty packed June ahead of me. So expect the full video on the version 2 of this press in maybe like, you know, 2 or 3 months or something, I don't know. Documentation and testing takes a long time. The printables page should have the new files for the upgraded gearbox, so head on over there if you want to upgrade your press now. I also included some longer rollers because people keep asking me to make a larger press, and my website now has the updated documentation, so if you're going to make the new you know, solid infill for the press body and new etching gears, the new documentation is on the website. Enjoy!